What role do civil engineers play in earthquake relief? Chile is in an area called the Ring of Fire. This is the meeting point of two tectonic plates, which gives rise to earthquakes whenever they move. The high seismicity of the area presents a problem for Chile, which can be solved through civil engineering work. Chile must be prepared for the eventuality of an earthquake, making sure structures resist the shock waves, and every aspect of the emergency situation has been planned carefully. Almost all Chilean residents, the economical development of the country, and the environment are affected by this problem, making it a pressing issue for the country. We will present 3 exemplar problems Chile was faced with during the 2010 earthquake, and explain how we, as civil engineers, would deal with them to find suitable solutions.
The O'Higgins Tower is a 241 office building completed in 2008 which collapsed partially on the 10th, 14th, and 18th floors during the 2010 earthquake in Chile. The shear walls in the east and south were severely damaged, and this caused the offices to shut down, throwing tens of hundreds of workers into unemployment. This is a clear example of how the lack of good anti-seismic engineering work could strongly impact the economic development of a country. To avoid the disaster of the O'Higgins Tower, some unique civil engineering work should have been done on the structure. First of all, the main body of the building should have been built on stable foundations. The newly designed anti-seismic buildings only stress after the release of seismic energy and have the ability of bending and swaying under the force of the earthquake without causing the collapsing of the structure. A newly designed office building would be beneficial to guarantee the safety of personnel and property in the building, making sure the economic benefit the country gains from the offices will be maximized.
The 2010 Chile earthquake had serious repercussions on the environment. An example of this was the failure of the Las Palmas tailing dam, which failed during the earthquake, causing toxic waste to be released into the local environment and killing 4 people. The dam was not designed to resist such a violent shockwave. Civil engineers have to design dams to withstand earthquakes when built in seismically active areas. This is done by incorporating the effects of liquefaction caused by the seismic waves and making sure there is a reasonable factor of safety. Liquefaction is a term used in material science to refer to any process which either generates a liquid from a solid or gas. The factor of safety ensures the stability of the structure during the worst possible case scenario.
This is the National Stadium of Chile, which is located in the capital of the country, Santiago. If the stadium starts collapsing in event of an earthquake, the evacuation of the audience will be of paramount importance. The way in which a proper evacuation can be done is by coming up with an efficient crowd management plan. This can include clear signaling, clear evacuation routes, and the avoidance of the clash between cars and pedestrians. If a proper evacuation is not carried out, people might start panicking and their behavior might become unpredictable. This will lead to chaos. And in a chaotic environment, many people may lose their lives.
In conclusion, you should now understand how civil engineering procedures are able to prevent natural disasters such as earthquakes from impacting human life in such a negative manner. It is therefore clear that civil engineering work in this field is of remarkable importance.